Artificial intelligence wasn't invented by Silicon Valley tech bros or even computer scientists. It was dreamed up by ancient Greek philosophers who thought they could turn human reasoning into a machine. 2,500 years before ChatGPT, Aristotle was writing instruction manuals for mechanical thinking. He called it logic, and he genuinely believed that if you followed his rules precisely enough, you could automate wisdom itself. The bizarre part? He was absolutely right. But it would take humanity over 2 millennia to figure out why. Here's the thing about intelligence that nobody talks about. We have no idea what it actually is. We know it when we see it? Sure. But defining it? That's where things get messy. The ancient world was obsessed with this problem. Greek philosophers weren't just navel-gazing about the meaning of life. They were trying to reverse engineer human thought itself. Aristotle's syllogisms weren't abstract philosophy exercises. They were blueprints. If all men are mortal, and Socrates is a man, then Socrates is mortal. Follow the pattern. Get the right answer. Every time. No creativity required. It was humanity's first attempt at building a thinking machine, except they were using brains instead of silicon. The Indians and Chinese were working similar angles with their own logical systems. But here's the kicker. None of them could actually build what they were describing. They had the software, but the hardware wouldn't exist for another 2,000 years. So the blueprints just sat there, waiting. Fast forward to 1854. A British mathematician named George Boole publishes a book with the wonderfully Victorian title, An Investigation of the Laws of Thought. Boole was a self-taught genius who thought he could capture human reasoning in pure mathematics. His big insight? Logic wasn't mystical. It was just really fancy arithmetic. True or false became 1 or 0. And became multiplication, or became addition. Suddenly you could solve logical problems the same way you solved algebra. Boole died young and poor, convinced he'd failed to crack the code of human thought. He had no idea he'd just invented the mathematical foundation for every computer and AI system that would ever exist. Talk about underselling yourself. Then came Charles Peirce, an American philosopher who took Boole's work and supercharged it. Peirce invented something called predicate logic, which is a fancy way of saying he figured out how to handle variables. Instead of, all men are mortal, you could write, for all x, if x is a man, then x is mortal. This was huge. It meant you could reason about entire categories of things without listing them individually. But Peirce was also spectacularly bad at self-promotion. Most of his best work sat unpublished in boxes. Meanwhile, in Germany, a mathematician named Gottlob Frege was having the same insights and actually publishing them. Frege wanted to rebuild all of mathematics from pure logic. It was an impossibly ambitious project, and it nearly worked. Then along came Bertrand Russell. Russell was the kind of intellectual celebrity we don't really have anymore. Brilliant mathematician, Nobel Prize winner, political activist, and serial marriage enthusiast. He read Frege's work and found a fatal flaw. Russell discovered what's now called Russell's paradox, which basically broke Frege's entire system. Imagine spending decades building the perfect logical fortress, only to have some British aristocrat point out that your foundation is sitting on quicksand. Frege was crushed. Russell felt terrible, but couldn't help himself. He spent the next chunk of his life trying to fix the problem with his collaborator Alfred North Whitehead. They produced the Principia Mathematica, 3 massive volumes that attempted to derive all of mathematics from pure logic. It was a magnificent failure. They proved that 1 + 1 = 2 on page 379 of Volume 1. The project was technically brilliant, but practically useless, and it raised a troubling question. If these geniuses couldn't mechanize simple arithmetic, how could anyone hope to mechanize thought itself? Enter the 1930s and 2 young mathematicians who would change everything, Alonzo Church and Alan Turing. Church was working on something called the lambda calculus, a way of defining computation itself. Turing was obsessed with a different question. What does it actually mean for a problem to be solvable? He invented his famous Turing machine, an imaginary device that could theoretically solve any problem that could be solved at all. Here's where it gets interesting. Church and Turing realized they were describing the same thing from different angles. The Church-Turing thesis basically says that anything you can compute on a Turing machine. This was the breakthrough nobody saw coming. If human thinking was just a form of computation, and Turing machines could handle any computation, then Turing machines could think. It was that simple and that revolutionary. Suddenly, artificial intelligence wasn't a philosophical pipe dream. It was an engineering problem waiting to be solved. Remember those ancient blueprints? Now they finally had a machine that could run them. Which brings us to the summer of 1956 and a small college in New Hampshire. Dartmouth College was hosting what would become the most important conference in the history of artificial intelligence. Except nobody called it artificial intelligence yet. A young researcher named John McCarthy had convinced the Rockefeller Foundation to fund a 2-month workshop on machine intelligence. The proposal was breathtakingly confident. We think that a significant advance can be made in one or more of these problems if a carefully selected group of scientists work on it together for a summer. These weren't just any scientists. The attendees included McCarthy himself, Marvin Minsky, Claude Shannon, and Herbert Simon. Between them, they would go on to win Turing Awards, Nobel Prizes, and basically invent computer science. But in 1956, they were just a bunch of optimistic researchers who thought they could crack intelligence in 8 weeks. McCarthy coined the term artificial intelligence, partly because it sounded more exciting than machine intelligence, and partly because he needed something catchy for the funding proposal. The conference was supposed to prove that machines could learn, use language, form concepts, solve problems, and improve themselves. They were convinced that within a generation, we'd have machines that could match human intelligence across the board. Spoiler alert, they were off by about 70 years and counting. But here's the remarkable thing. Almost everything they discussed that summer eventually came true. Machine learning? Check. Natural language processing? Check. Computer vision? Check. Even their wildly optimistic timelines, though wrong in the short term, captured something essential about the trajectory of the field. They understood that intelligence wasn't magic. It was pattern recognition, search, and clever bookkeeping. They just underestimated how much pattern recognition, search, and clever bookkeeping it would take. So here we are in 2026, watching AI systems write poetry and paint pictures, and having philosophical debates about consciousness with chatbots. The strange thing is, we're still running on those ancient Greek blueprints. Every time an AI makes a logical inference, it's following rules that Aristotle would recognize. Every time it processes language, it's using mathematical insights that trace back to Boole and Frege. The optimism of the Dartmouth conference turned out to be both completely wrong and surprisingly right. Wrong about the timeline, right about the possibility. These pioneers got the destination exactly right, but they had no idea how long and winding the road would be. They thought they were building HAL from 2001. Instead, they built autocomplete on steroids. But maybe that's enough. Maybe intelligence isn't about being human. Maybe it's about being useful. And maybe the real lesson of this whole strange history is that our biggest breakthroughs come not from trying to replicate ourselves, but from trying to understand what thinking actually is. The philosophers started that conversation 2,500 years ago. We're still having it today. And honestly, that's probably exactly how it should be.